Okay, good morning, good morning. Hello, everyone. I think now it is live. Good morning. How are you all? Okay, nice. Good morning, everyone. So, our topic is going on, that is kinetics. Okay, so now we are doing the analysis of motion as well as the analysis of forces. Okay, so on this, further, I am going to take the more problems on the kinetics. Okay, more problems on the kinetics I am going to take. Okay, so we have done yesterday up to the last question of connected bodies, where bodies were connected by some means of a string, and also we have done the problem of friction with block over block, with block over block. Okay, so now let's move further and take more problems on the connected bodies. Okay, chaliye. Good morning, everyone. So here you can see this is the profile, and we are covering here complete course of engineering mechanics. Okay, this is the complete course for all the papers, gate papers, and for different competitive exams. Okay, everywhere it is useful. And those who want to join the free telegram group, this is the group, you can join this group. Simply search with Mudit Raj sir group. Those who want to join paid courses, they can just message me on telegram on this number, personal message. Okay, so let's start. So we have done up to this was the problem, then we have also taken this problem at last. So now let's move ahead and take more problems. Write down next problem. All done up to this? Okay. Write down next problem. Like simple single pulley system. If initially system is at rest, if initially system is at rest, then find the acceleration of blocks. Then find the acceleration of blocks and tension in string, and tension in string when system is released from rest, released from rest. Take g equals to 10 meter per second square. Okay, g का value we have to take 10 meter per second square. Okay, now let's say system is given to you like this is a pulley and nothing is said about the pulley, so pulley is actually ideal pulley, ideal pulley. Okay, here two blocks are hanging with the help of a string like this, with the help of a string like this. Okay, one block, let's say this left block is of 100 Newton and this right block is of 50 Newton. That's it. Okay, so when it will be released from rest, what will be the acceleration and tension? ये अपने से पूछ रहा है. तो first thing, nothing is said about the pulley, so pulley will be your ideal pulley. Pulley will be your ideal pulley. Ideal pulley means massless and frictionless. Massless and frictionless. Okay. Now here there is a string. So first of all, we will apply the tension in the string. We will apply the tension in the string. Okay. So let's say this is the tension T in the string. So everywhere both side in this string tension will be same because pulley is frictionless. So tension both side will be equal. Okay. T and T. Now you can draw the FBD. The weight of right side block W2 will be acting like this and weight of left side block will be acting like this. Okay. Now when system will be released, for damn sure it will be in motion. Yes or no? For damn sure it will be in motion. This is more weight, so it will go down by acceleration A, let's say, and it will go up by same acceleration because they are connected. Both are connected by same string. So same acceleration will be there. So now when you are drawing the FBD, you have to draw acceleration also. Acceleration also. Now the FBD is complete. Now the FBD is complete. Yes or no? So for the FBD, what you can do, you can simply cut it down like this. Yes or no? You can simply cut it down like this. FBD is this. So here let's apply the equation of forces for both the blocks. Okay, equation of forces for both the blocks. And also here in this pulley, let's say this is also one tension. This is also one tension like this. This is also a string. So let's say here also tension will be there like T dash. Like T dash. There is no need, but you can draw FBD of this also. So for this FBD you will cut it. Yes or no? So FBD of pulley will be like this. FBD of pulley will be this. Okay. FBD of this block will be this. FBD of this block will be like this. That's it. Okay. So these are the FBDs. So for the upper pulley, they are not asking, but if they ask someday, then you can answer. So for the upper pulley, you can write that pulley is in rest. So summation Fy will be equal to 0. So for that, plus T dash upward and minus 2T downward. So T dash will be equal to 2T. Simply I can write. Yes or no? So this is for this pulley. पूछा नहीं है बट अपन ने बता दिया. वी आर लर्निंग हेयर मैनी थिंग्स. ओके, सो इफ दे आस्क यू, यू कैन टेल देम लाइक दिस. नाउ फॉर दिस ब्लॉक you will apply equation in y direction, summation Fy My like this. So forces in y direction plus T minus W2 equals to M2. This will be block M2. M2 will be 5 kg because G is your 10. Okay, and A is upward, so you will take plus A. So equation will be T minus 50 equal to 5A. Second equation. Now for this block, what will be the equation? Summation Fy equal to M1 AY. ऐसे होगा. So plus T minus 100 equals to 10 into, acceleration is downward, so it will be minus A. Minus A. So here you can write 100 minus T will be equal to 10A. So these two equations are there. So in these two equation T and A, two equation, two unknown, solve कर सकते हैं ना? कर सकते हैं. So from equation 2 and 3 you can solve them easily. जैसे आप फर्स्ट इक्वेशन से सॉल्व करो, t इक्वल टू कितना हो जाएगा? 50 प्लस 5a. यस और नो? सो पुट इन द थर्ड इक्वेशन 100 minus t is equal to 50 plus 5a, okay, equal to 10a. So here it will be 100 minus 50 minus 5a equal to 10a. So here 50 equals to 15a. So your acceleration will be equal to 3.33 meter per second square. Got the point or not? Meter per second square. Okay. Got the point? Now you can also find the tension. So here from equation 2, put the value of a in equation number 2. T minus 50 equal to 5 into 3.33. So simply you will get here 50 plus this will be your 5.33. So you can multiply here like this. Okay. So it will be your 66.6 like this Newton. So this will be value of tension. Okay. So simple. So the procedure is like this. Also you can find the T dash. What will be the value of T dash? T dash is 2T. So you can write here multiply by 2. It will be 133.3. 133.3 like this. Yes or no? Okay. Everyone clear up to this? Write down Jai Hind. Very good. T is 66.6. Okay. Now look here, one more thing. This acceleration will be constant or not? Value of this acceleration will be constant or not? Hoga, it will be constant. Yes or no? So this acceleration will be constant. These tensions will be also constant. So if I ask you how much distance this block will cover, let's say in 10 seconds. Let's say in 10 seconds. तो फाइंड कर सकते हैं कि नहीं? Can you find it? Or what will be the velocity of this block after 10 second V10? Can you find it? Yes or no? तो अब आपसे कुछ भी पूछा जाए that you can find. Okay. तो इसी में अगर मैं लिख देता हूं in same problem also find velocity and distance covered, distance traveled by block 1 after 10 seconds. 10 seconds. So actually we have to find what? V10 and H10. Okay. So as we know acceleration is constant, so you can apply three equations of motion. So you will write here, because acceleration is 3.33 meter per second square and it is constant. Okay. Now here V equals to U plus AT you will apply. So V with 10 will be equal to 0 plus acceleration is this much and time is 10 seconds. So V10 will be equal to actually 33.33 meter per second. Okay. So this will be the case. This will be velocity, and velocity we know for the first block it will be downward. Yes or no? Because first block is going downward. That is of large weight. Second, how much height it will drop down. So height you can find, or distance you can find by this. So simply ut plus half at square. Now half into 3.33 into 100 बन जाएगा टी स्क्वायर. ओके ओके ओके. So here the total value when you will find it will be, check it out, 166.5 meter. 166.5 meter. So it will be also downward for the first block. Downward for the first block. Second block will go up by same amount. Yes or no? 166. Very good. All done. Nice. Next problem, or in same problem, I am adding one more thing. Apply work energy principle for 10 seconds. Apply work energy principle for 10 seconds. 10 seconds. And again find V10. And again find V10. Velocity after 10 seconds you have to find. तो वर्क एनर्जी प्रिंसिपल आपको लगाना है. सो वर्क इज गिवन बाय चेंज इन काइनेटिक एनर्जी. चेंज इन काइनेटिक एनर्जी. ओके. सो नाउ फॉर होल सिस्टम यू विल अप्लाई दिस. ओके. सो इन अवर सिस्टम विच फोर्सेस आर डूइंग वर्क. तो देखो जरा, this is the external force W1. This will perform work and it will go down by, let's say, h10 distance. So force into displacement will be work done, and this work done will be positive because force is downward, displacement is also downward. Second, this force will perform negative work because force is downward but displacement h10 will be upward. Yes or no? So total work done by this force will be negative. Okay. Finally, two masses m1 and m2 will be moving with V10. This will be moving downward and this will be moving upward, but kinetic energy for both half mv square will be positive because V square is there, so nothing plus minus you will see there. So directly I can apply how many forces are doing work. So first I will apply for the W1. So plus W1 into H10, this will be the positive work, minus W2 into H10, this will be the negative work, equals to half M1 V10 square plus half M2 V10 square. टोटल सिस्टम का काइनेटिक एनर्जी ये है फाइनल. इनिशियली both blocks were at rest, so initial velocities were 0. Yes or no? So put here the values. 100 Newton into, what is the value for H10? 166.5 minus W2 is 50. 166.5 will be equal to half. M1 is your 10 V10 square plus M2 is your 5 V10 square. Okay. So here V10 you can take common. Okay. So total will be equal to 50 into 166.5. Okay. 100 minus 50. And here V10 square you can take common. So it will be half into 10 plus half into 5. Simple. So you can calculate here V10 once again. You will get same value 33.33 meter per second. So this is the method work energy method. By this also you can calculate the velocity. Clear हुआ कि नहीं बोलो? Everyone clear up to this? Same answer मिल रहा है? Yes or no? Same answer you are getting? बोलो बोलो बोलो. सेम आंसर मिल रहा है बेटा? गुड. नाइस. Good, good. Now, in same pulley, if I apply friction also, okay, let's say same problem in the pulley, abhi pulley was smooth, but now I am considering, let's say friction is also there. So write down, in same problem, if pulley is rough, okay, then check the state of system. Check the state of system for mu equals to 0.1. For mu equals to 0.1. तो जैसे मान लो this is the pulley and this is the rough pulley and mu is given for this. Okay, this is the block 1 and this is the block 2. Block 1 and block 2. So W1 same problem 100 Newton, W2 same problem 50 Newton. Okay, but this time this pulley is rough and mu is equal to 0.1. Here we know for the rough pulley the tension on both sides will not be equal. Tension on both sides will not be equal. One side will be maximum. So maximum we will always consider T1. ये बेल्ट फ्रिक्शन अभी मैं कराऊंगा आपको टॉपिक. फॉर नाउ अभी एक ही फॉर्मूला है तो इसको समझ लो. And this side tension will be minimum because less weight is there. So this will be T minimum. So one side will be maximum, one side will be minimum. This is more weight. So this side tension will be maximum. This side minimum tension will be there. Tension on both sides will be unequal. Now, what will be the formula for this T1 and T2? So first formula we will hear for the belt friction, T maximum over minimum equals to T1 over T2 equals to e to the power mu theta. E to the power mu theta. Okay, where theta is lap angle. Where theta is what? Your lap angle or angle of contact but it is always in radians. Always in radians you have to take theta. So here theta will be what? Look here. यहाँ contact is starting here up to here. So actually your theta will be this. Yes or no? So string is in contact with the pulley over this length of contact. So this will be your angle of contact. Pi हो जाएगा. Pi. So one equation between T1 and T2 you will get here. One equation T1 and T2 you will get here. So T1 will be equal to T2 times into e to the power mu. Mu is 1 and theta is pi. This will be the value. So T1 will be equal to actually 1.369 T2. One equation is this between T1 and T2. Okay. between T1 and T2. Now acceleration is also unknown. So total unknown are 3, T1, T2 and acceleration. Okay. So here this system will start to move. This system will start to move and FBD will be like this. Here it will be W1 and here it will be W2. Okay. Here it will be W1 and here it will be W2. It will go down by A acceleration. It will go up by A acceleration like this. Okay. And for FBD you can cut it like this. For FBD you can cut it like this. So for the first block, what equation you can apply? Summation Fy equals to My. So this is M1. So summation Fy plus T1 minus W1 equals to M1 into minus A. So actually equation will become 100 minus T1 equal to 10A. Third equation. For the second block, you will get summation Fy equal to M2Ay. M2Ay. So it will be plus T2 minus W2 plus T2 minus W2 equals to M2 into A like this. Okay. So what will be the equation here? T2 minus 50 equals to 5A. Fourth. So total now there are 3 equation. Equation 1, equation 2, equation 3. 3 equation 3 unknown. आप इसको सॉल्व कर सकते हैं। अब बड़े प्यार से आप इसको सॉल्व कर सकते हैं। मैथमेटिक्स आप अप्लाई करना, ठीक है। सो what to say, you will get answer. check your answers at the end. चेक करो, ये आपको आ रहा है 81.269 ऐसे आएगा कुछ। T2 you will get 59.364. okay, and acceleration you will get 1.872 meter per second square. meter per second square. ओके, तो चेक इट। किस किस को मिल रहा है सेम? रफ पुली में एक्सेलरेशन, बेटा स्ट्रिंग तो एक ही है ना, एक्सेलरेशन तो सेम ही होगा। वेरी गुड, एक्सेलरेशन तो एक ही होगा, रफ हो या स्मूथ हो, बिकॉज लेंथ ऑफ स्ट्रिंग कैन नॉट चेंज। स्ट्रिंग का लेंथ तो वही है ना, स्ट्रिंग का लेंथ तो वही है, वेदर इट इज रफ पुली और स्मूथ पुली, नो प्रॉब्लम। नाउ लेट्स कंसीडर ए केस ऑफ डबल पुली सिस्टम। ओके, तो आपसे कह रहा है फाइंड द एक्सेलरेशन of blocks if system is released from rest. If system is released from rest. Okay, take G equal to 10. Take G equal to 10 like this. Now draw here double pulley system. Let's say this is one pulley and this is another pulley, and let's say this pulley is connected here like this. like this, and here weight of this block is W1 100 Newton is given to you, okay, and this is given to you W2 50 Newton, okay. कहता है when system will be released, what will be the acceleration of blocks? So you can see here that this pulley will not move. It is connected with this string, but this is a free pulley. This pulley can go up and down, yes or no? So this is a free pulley, yes or no? And in the chapter of virtual work, I have given you the relation between acceleration of this and acceleration of this, velocity of this and velocity of the displacement of this and displacement of this. Already I have given you the relation, so that relation now we will use here. First of all, there are strings. How many string? One. This total is single string. Second string, third string. So let us assume tension everywhere in the strings. So this will be the same string everywhere. The tension will remain same. T1, 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 T2, T2, T2 T1. T1 like this. Okay, that's it. Now here you can assume the tension T3. Assume the tension T3 like this. Okay. So for the FBD, you will assume T2 tension this also and apply weight here 50 Newton. Here also you will apply the weight. This will be your 100 Newton. Okay. Now acceleration will be how? Let's say this is going downward by A1 acceleration, let's say A1, and A1 is equal to A, let's say. Then this will go upward by A2 acceleration, and A2 will be how much? A by 2. Already I have given you the derivation in virtual work chapter. Okay, that's it. Now look at this pulley. This pulley is free pulley, so this pulley can also move, but pulley is given to you ideal, so it is massless body. Nothing is said means it is ideal pulley, so it is massless, yes or no? So for FBD, what you will do? You will cut this string, and cut this string, cut this string. Now FBD are completed. So now, first of all, consider the FBD of this pulley. Okay. So for this pulley, look simply, its mass is 0. So apply equation for free pulley. For free pulley, summation Fy equal to My. So plus का 2T1 minus का T2 equal to its mass is 0. Acceleration is whatever. Acceleration of this will be equal to this. Okay, A by 2. Both will move together. So it will be actually 0. So 2T1 will be equal to T2. So equation number 1 will be there. Second, the relation between the accelerations A1 will be equal to 2A2. Already given you derivation. Third equation, for the first block, summation Fy equal to M1Ay. So plus का T1 minus का 100 equal to M1 into minus का A. Or you can write down A1, A or A1, whatever you consider. Okay, so this will be actually 100 minus T1 equal to 10 A1. Okay, 3. Next, fourth equation you can apply, summation Fy equal to M2 Ay. तो व्हाट यू विल अप्लाई, प्लस का T2 माइनस का 50 इक्वल टू, प्लस का T2 माइनस का 50 इक्वल टू M2 is 5 and A2 is upward, so it will be like this. So equation will be T2 minus 50 equal to 5A2. Okay, 5A2. So 4 equation, 4 unknown. 4 equations are there. 1, 2, 3, 4. 4 unknown, T1, T2, A1, A2. If you will put here A, 10A, and if you will put here 5A by 2 like this, then 1, 2, 3 equation will be there and 3 unknown, है ना, T1, T2 and A. So either you can make 4 equation 4 unknown or 3 equation 3 unknown. Okay, so I have given you the general case, 4 equation 4 unknown. इसको solve करो फटाफट और आंसर बताओ मुझे. सॉल्व करो आंसर बताओ. So check, I am giving you the answers. T1 will be equal to 33.33. T2 will be equal to 66.66. A1 will be equal to 6.66. A2 will be equal to 3.33. Anyone who are getting all correct answer? Anyone who is getting all correct answer? बोलो बोलो बोलो. मिल रहा है ना? वेरी गुड वेरी गुड. सुपर. Okay, so now अरे ये कहाँ गया? हैंग हो गया क्या? What happened to this? Just 1 second. हाँ, now it is okay. मिल रहा है ना? गुड. चलिए आगे बढ़ते हैं. नेक्स्ट प्रॉब्लम लेट अस कंसीडर. Next problem, let us consider. I am giving you a block which is moving on inclined plane like this. If block is released from rest, block is released from rest, its velocity when it will hit the bottom, find its velocity when it will hit the bottom. It will hit the bottom. So आपको this is the inclined plane. This is the inclined plane and block is placed here initially. Block is placed here initially. Okay, like this. And this is rough inclined plane. This is rough inclined plane. The angle of inclination is 30 degree and mu s is given to you 0.3. Mu k is given to you 0.2 and distance s is given to you 10 meter. Like this. Initially it is at rest, u equals to 0 and its weight is 100 Newton. Okay, and when it will hit the bottom here, what will be the velocity? So you have to actually find this velocity here. How much will be the velocity after 10 meter? Okay, कर सकते हो क्या इसको? बोलो. Take g equal to 10. Take g equals to 10 meter per second square. Simply draw the FBD, then start. तो यहाँ because friction is there, first of all we have to check कि ये motion करेगा भी कि नहीं. क्या पता due to friction it will not move. Okay, due to self weight. So we have to check first. So we can directly check by the angle of repose. Yes or no? Angle of repose से check कर सकते हैं कि नहीं? So angle of repose क्या होता है? Tan inverse mu s. Yes or no? Tan inverse mu s. So here it will be tan inverse mu s is 0.3. So its value will be actually 16.69. Now as the angle of plane is 30 degree and it is more than the angle of repose, so my block will be in motion. Motion is there. Block will be in motion. तो फ्रिक्शन कौन सा लग रहा होगा? काइनेटिक फ्रिक्शन. यस और नो? सो फ्रिक्शन विल बी काइनेटिक फ्रिक्शन and it will be equal to mu k into n upward. Okay, so this will be your kinetic friction acting on the block like this. अभी इसको properly हम लोग solve करते हैं by FBD. So by FBD you will draw the block here first. You will draw the block here first. This is the block. Okay, so on the block you will apply all forces. कौन कौन सा फोर्स लग रहा है? इन दिस डायरेक्शन W cos थीटा, W sin थीटा. अरे उल्टा लिख दिया. W sin will be here, W cos will be here. Normal reaction. Okay, and friction will be upward. Which friction? Kinetic friction. And when we will release, it will start to move. So acceleration will be also there. Yes or no? Acceleration will be like this. Now only FBD is complete. FBD is now completed. So there are two directions, X dash and Y dash. So we can make the equations in these directions. Okay. So first apply in y dash direction summation fy dash ma dash. So in y dash there is no acceleration. So plus n minus w cos theta equal to 0. So n equal to w cos theta हो जाएगा. So it will be 100 cos 30, 86.6. 86.6. This will be the value of normal reaction. होगा 86.6. Now in x dash direction you will apply the equation summation fx dash ma x dash. So माइनस का w sin थीटा डाउनवर्ड प्लस का एफ के अपवर्ड इक्वल टू मास इंटू माइनस का ए डाउनवर्ड, मास इंटू माइनस का ए डाउनवर्ड हो जाएगा. सो द इक्वेशन विल बिकम w sin थीटा माइनस एफ के इक्वल्स टू एम ए होगा. सो w sin थीटा विल बी योर 50, 100 sin 30, एफ के विल बी योर म्यू के इज हाउ मच, म्यू के दिया है 0.2, 0.2 into n 86.67 equal to mass will be 10 into acceleration a. So from here actually you will get the value of acceleration मिलेगा. So check it, what is the value, 3.268 is the value, yes or no. तो ये आपको मिल जाएगा value of acceleration. So by the equation of forces you actually get the value of acceleration. Okay, now further analysis of motion can be done. Now further analysis of motion can be done. Now this acceleration will be constant or not? Yes beta, it will be constant. Okay, because this force is constant and Fk is also constant, mass is constant, so everything is constant except S, means whole equation A will be also constant. Now further analysis, acceleration is constant and they are asking you the velocity after 10 meter. Velocity after 10 meter they are asking. So which equation you can apply? Three equation of motion, yes or no? V square equal to U square plus 2AS. Clear? So V is V square and U is 0 plus 2 into A value is 3.268 into distance 10. Okay, so from here you will put and अंडर रूट करेंगे, सो टोटल वैल्यू विल बी दिस मच, ये वैल्यू आएगा. मिल रहा है कि नहीं? सो दिस विल बी योर आंसर, दिस विल बी योर आंसर. ठीक है. Same value of the velocity you can get by work energy principle also. Same value of velocity you can find by work principle also. Okay, so let apply work principle also, work energy principle also. यहाँ भी हम वर्क एनर्जी प्रिंसिपल लगाते हैं. ओके, सो वर्क विल बी इक्वल टू चेंज इन काइनेटिक एनर्जी ऑफ द ब्लॉक. नाउ which force will do work? Look in the FBD. This force will not do work, this force will not do work because both are perpendicular to the direction of motion. So these two components will not perform work. वर्क कौन करेगा? W sin theta will do positive work because force and displacement are in same direction. Friction kinetic will do negative work because displacement is opposite. So this will do positive work, this will do negative work. So there must be net force in the direction of displacement. So net work we can find. Yes or no? So the net work will be given by net force in the direction of displacement into displacement equal to half mv square minus half mu square होगा. हाफ mv square minus half mu square. u is 0, ये 0 हो गया. नेट फोर्स क्या होगा? पॉजिटिव वर्क कर रहा होगा आपका w sin थीटा माइनस निगेटिव वर्क कर रहा होगा एफ के इंटू 10 इक्वल टू हाफ एम वी स्क्वायर. ओके, सो पुट ऑल द वैल्यूज हेयर, इट विल बिकम 50 माइनस 0.2 into 86.67 into 10 equals to half into 10 into v square. Again you can check the value of v. It will be the same value 8.08 मीटर पर सेकेंड. यस और नो. इससे भी बोलो आपको सेम आंसर मिला कि नहीं मिला. सेम वैल्यू यू आर गेटिंग. सो सेम वैल्यू यू आर गेटिंग बाय वर्क एनर्जी प्रिंसिपल ऑल्सो. क्लियर हुआ सभी को. बोलो बोलो बोलो. हाँ 8.08. वेरी गुड. 8.08. Same value you will get. Okay. गायरोस्कोप के लेक्चर देख रहा हूँ. So now you will be master in theory of machine. You will be master in gyroscope. You can answer just in 3 seconds, है ना. Maximum 6 seconds you will take. You can answer of the gyroscope instantly by our particular method, है ना. Moody's method, है ना. Mudit Raj method. So just like the Mohr circle method in the SOM, Mohr circle sir has developed. So this method is developed by your sir, Mudit Raj sir. Okay, so just in 6 seconds, only in 6 seconds you can solve the gyroscope. Very good. अगर आपको उधर समझ आ गया then it is very nice thing. Good, good, good. Those who are sincerely attending all the lectures, for damn sure they will get everything. Only 5 to 6 seconds it will take to answer the question. Yes or no? Very good, very good. चलिए. So now same value you all are getting for the velocity. Now let's take one more problem. So all the problems here also you can solve by same method. Any problem of the world you can solve by same method. Okay, but we have to strict with the level of gate and ESC only, because level of problem can be very tough or very easy, but we have to check which exam we are going to attempt. According to that level of difficulty I am giving to you. Okay. Now if block B and C, write down next problem. Find the weight of block A if block B and C move together without relative motion. Without relative motion between them. Okay, all surfaces are smooth. All surfaces are smooth and take G equals to 10 meter per second square. G equals to 10 meter per second square. So let's say these are the two blocks. B and C. B and C. These are placed here on a table. Okay. This is a pulley. It is fitted with the table and it is at rest. Here, this is block B. This is block C, and let's say this is block A. Block A is not touching the table, okay? There is no contact here. And all smooth surfaces. All surfaces are smooth, simply. Okay. Now, weight of this block B is given to you 100 Newton. Block C has 50 Newton weight, and this angle is 30 degree. Theta is 30 degree. When we will release this system, what will happen? What will happen? A ka weight will be acting here. A ka weight will be acting here, WA. Okay. Tension T will be acting here. Tension T in this string will be like this. So on this block, it will be acting at this point. So due to this T, this block system B and C will move together right side. Yes or no? Just like that problem. Already we have done this problem na. इसमें P force लगाया था. Then there was no relative motion between upper and lower block. उसको डीलम्बर्ट से भी किया था, न्यूटन से भी किया था. Same thing here. There is no P force, but here this tension T should be such that इसके बीच में relative motion नहीं होना चाहिए. Both these will move like a single system. बात क्लियर हुई? So we have to find the actually tension T. So tension T मिल जाएगा. Then by solving this block you can find the weight A. You can find the weight A. Problem clear हुआ? Okay. So now for the FBD, what you can do? For the FBD, what you can do? You can simply cut this string. You can simply cut this string and you can cut this string. So they will be cut down. Okay. So they will be cut down for the FBD. Now, when system will be released, it will have, let's say, A acceleration downward. It cannot go up. So damn sure acceleration will be downward. Yes or no? And this whole system will also start moving right side with same acceleration because same string is there. Okay. So now apply the equations. Apply the equations for block A. First of all, for block A, summation Fy equals to MAY. Summation Fy, MAY. So here you will apply plus ka T minus ka WA equal to mass of block A into your acceleration of A, that is downward minus A. So here you can write WA minus T equals to M into A, and first equation this will be clear. First equation simply this will be. Now upper two block will start moving together. Upper two block, ये A block का let's say बना देता हूँ FBD. What will be FBD? WA and A is the acceleration. For upper two block, they will start moving together. They will start moving together. as a single system because no relative motion should be there. So we are considering that there is no relative motion between them. So just like a single system they will move. Here tension T is acting. Okay, tension T is acting. Total weight, यहाँ इनका कहीं total center of gravity बनेगा. So total weight 150 Newton will be acting. 150 Newton will be acting, and total normal reaction will be acting like this. Okay, let's say this normal reaction is N simply, or you can say NB. B block पर लग रहा है तो NB मान लेते हैं इसको. Now this whole system is moving with acceleration A right side. Acceleration A right side. So for whole system you will apply summation fx equal to max. So plus का T right side, only one force. Mass will be the total mass mb plus mc into A होगा. So T will be equal to mb is 10, mc is 5, so A equal to 15A बन जाएगा. Yes or no? T equal to 15A ये बन जाएगा आपका. Now third, now we will consider the individual FBD of block C. Individual FBD of block C like this. This is your block C. How many forces are acting on the block C now? So for the block C, first of all, इसका 50 cos theta will be here, 50 sin theta will be here. Normal reaction NC will be here like this, and surfaces are smooth, so no friction is there. No friction is there. अभी इसको हम डीलम्बर्ट से सॉल्व कर सकते हैं क्या? इसका एक्सेलरेशन राइट साइड होगा, सो इस पर Fi जो होगा दैट विल बी एक्टिंग लेफ्ट साइड. Fi का वन कंपोनेंट यू विल ड्रॉ लाइक दिस along the plane, and second will be perpendicular to the plane. Because this is the angle theta, so it will be Fi cos theta, and this will be Fi sin theta. Yes or no? बन जाएगा ये. So इससे what we can do, we can now apply equations in x dash and y dash directions, and it is in dynamic equilibrium. आपने inertia force लगा दिया, imaginary inertia force, so now it will be sorry, it will be in dynamic equilibrium. Okay, so here you will apply first summation fx dash equal to 0 है ना. तो माइनस का 50 साइन थीटा डाउनवर्ड प्लस का Fi cos थीटा अपवर्ड इक्वल्स टू 0. यहाँ आप लिख सकते हैं 50 साइन थीटा इक्वल्स टू Fi cos थीटा बन जाएगा. 50 साइन 30 इक्वल टू Fi कितना होगा, मास ऑफ द ब्लॉक सी इंटू एक्सेलरेशन है ना, इंटू कॉस 30, ऐसे बन जाएगा. ठीक है. तो मास ऑफ द योर सी ब्लॉक वो कितना होगा, मास ऑफ द सी ब्लॉक, मास ऑफ द सी ब्लॉक किधर दिया हुआ है, 50 न्यूटन है, 5 हो जाएगा. 5. ओके, सो ये बचेगा 25, ये आ जाएगा 5, ये आ जाएगा A, ये आ जाएगा cos 30. cos 30 की वैल्यू कितनी आएगी, cos 30 0.8 ओके, ये बन जाएगा। तो इससे ये जाएगा 5 टाइम्स, सो 5 डिवाइडेड बाई आंसर, मतलब ये आ गया 5.773 मीटर पर सेकंड स्क्वायर। तो आपको एक्सेलरेशन की वैल्यू आ गई, दिस मच एक्सेलरेशन विल बी रिक्वायर्ड। ठीक है, इस एक्सेलरेशन को हेयर यू कैन पुट, देन यू विल गेट द वैल्यू ऑफ टी, यस और नो, पुट इन टू, सो फ्रॉम टू t will be equal to your 15a इंटू 15 कर दो, 86.6 आ गया, 0 न्यूटन। ये आपका आ गया t का वैल्यू। ओके, नाउ पुट दिस t वैल्यू इन this equation, okay, and this mass will be of mass of block A, so from equation 1 कितना कितना है, WA माइनस टी इक्वल टू MA, WA माइनस टी इक्वल टू MA, A is 5.773, क्लियर हो जाएगी बात। सो हेयर at the place of WA you can write MA into G, then minus MA into 5.773 को लेफ्ट में ले आओ एंड 86.6 को राइट में ले जाओ, सो इट विल बी MA into 10 minus 5.773, 4.227 आ जाएगा, ये सुनो। तो यहाँ से मास ऑफ ए निकल आएगा, मास ऑफ ए 20.48, 7 kg। सो डब्ल्यू ए कितना होगा, आपको डब्ल्यू ए पूछा है, इंटू 10 कर दोगे तो 204.87 न्यूटन बन जाएगा कि नहीं। सो दिस इज योर आंसर, दिस इज योर आंसर, दिस इज योर आंसर। चेक करो कोई कैलकुलेशन मिस्टेक तो नहीं हुई, चेक करो, क्योंकि कैलकुलेशन मिस्टेक हो सकती है। सबका यही मिल रहा है। All are getting these values, very good। नाइस, आगे बढ़ा जाए, आगे बढ़ते हैं। तो लेट्स डू वन मोर प्रॉब्लम, ऑन दिस। बहुत सारी प्रॉब्लम, हर वैरायटी का प्रॉब्लम वी आर डूइंग। Write down. Find the normal reaction at all contact surfaces. At all contact surfaces. Okay. If all surfaces are smooth, if all surfaces are smooth, and M block is released from rest, and block M, small m, is released from rest, तो अपन क्या करेंगे, लेट्स से ये ब्लॉक है, okay, this one is a block and this block is of, let's say, capital M mass. This block is of, let's say, capital M mass. Okay, now small mass M block is here, and here it is a fixed support type. This is a fixed support type like this. Okay. So now when this block of small m will be released, so when this block of small m will be released like this, then you have to check what will be the normal reactions. नॉर्मल रिएक्शंस. सो नॉर्मल रिएक्शन, एक तो ये कॉन्टैक्ट सरफेस है, दूसरा ये कॉन्टैक्ट सरफेस है, तीसरा ये कॉन्टैक्ट सरफेस है. ऑल थ्री नॉर्मल रिएक्शन यू हैव टू फाइंड. क्लियर हुई बात? ओके. सो लेट्स start the problem by FBD. So first of all, draw FBD of the small m block. जो अपर ब्लॉक है उसका हम बनाते हैं FBD. Okay. So let's say this is the block, small m block. And here forces will be what? This will be your mg cos theta, as we know. This will be your mg sin theta, as we know. And this will be the normal reaction N1. And here one more thing. क्या रह गया बनाने को? क्या रह गया बनाने को? एक्सेलरेशन. बिना एक्सेलरेशन के FBD विल नॉट बी कंप्लीटेड. सो लेट्स से जैसे इसको छोड़ेंगे, एक्सेलरेशन A विल बी एक्टिंग लाइक दिस. A विल बी acceleration downward like this. ठीक है. So apply the equation. Simply apply the equation. First apply in, let's say, y dash direction. Summation f y dash ma y dash. So in y dash there is no acceleration. So it will be plus n1 minus mg cos theta equals to 0. So simply n1 will be equal to mg cos theta. No problem. No problem. Second, apply equation in x dash direction. M a x dash, what it will be? Minus का mg sin theta downward. Only one force, m into minus का a. So a and a will get cancelled. Sorry, m and m will get cancelled. Acceleration will be actually g sin theta. G sin theta. Your acceleration of upper block will be g sin theta, and g is constant, sin theta is constant, theta is constant, so this acceleration will remain constant. Now let's draw FBD of this block, triangular block. इसका FBD बनाओ. So in FBD of this block, first of all, normal reaction is acting on this block upward, so equal and opposite will act on this block. Okay, equal and opposite on both the blocks. So N1 will be acting first of all on this block like this, perpendicular to the surface. Yes or no? Like this. Now weight of this block, own weight इसका capital Mg, and here let's say normal reaction is N2. ऐसे एक्ट कर रहा है. This is angle theta. From the right side, wall or surface, let's say normal reaction is N3. Normal reaction is N3. Here, check the acceleration. There is no acceleration in x direction and there is no acceleration in y direction. ना x में है ना y में है, इसमें acceleration ही नहीं है. Clear? And this is theta. So actually this angle will be theta. From the vertical, this angle will be theta. Yes or no? So this will become the n1 cos theta component and this will become n1 sin theta component. So for this block you will apply the equation in let's say y direction first, summation fy equal to may, ay is 0, so प्लस का n2 अपवर्ड है, माइनस का mg डाउनवर्ड है, माइनस का n1 cos थीटा डाउनवर्ड है इक्वल टू 0. So your n2 will be capital mg plus n1 cos थीटा, और n1 कितना है mg cos थीटा, so mg cos थीटा into cos थीटा, this will become the value mg cos theta plus cos theta. Clear? Small mg cos theta. So it will be equal to, if we take g common, m plus m cos square theta into g. This will be the value of n2, second normal reaction. Now when you will go in x direction, there will be the value of third normal reaction, प्लस का n1 sin थीटा, प्लस का n1 sin थीटा like this, and माइनस का n3 will be equals to 0, will be equals to 0. So your n3 will be equal to n1 sin theta, n3 will be equal to n1 sin theta. Okay, clear हुई बात? This will be the value, this will be the value. So all normal reactions are calculated. तो ये जो normal reaction आ रहा है ना N3, it will be obtained when they are in upper block is in motion. यहाँ पे लिख दो, if block M is fixed or stick to block capital M, then there will be no motion. In that case n3 will be equal to 0 and n2 will be equal to total weight. टोटल वेट के बराबर हो जाएगा m plus mg. So everything will be in statics. So in statics n3 will be 0. n3 will be 0 in that case. Okay, clear हुआ सभी को? बोलो. Everyone clear with this? बोलो बोलो बोलो. सभी को क्लियर हुआ? Good. So this was the problem for different normal reactions. Different normal reactions. Okay. अभी इसके आगे हमारा डायनेमिक्स में और प्रॉब्लम्स है, दैट आई विल कंसीडर टुमारो. ठीक है. आफ्टर दैट वी विल स्टार्ट द टॉपिक ऑफ, हमारा ये प्योर ट्रांसलेशन हुआ. Then we will start the topic of linear momentum, collision, all these things. Okay, क्योंकि ये प्योर ट्रांसलेशन का पार्ट है, तो अभी बहुत सारे और क्वेश्चन करने हैं हम लोगों को प्योर ट्रांसलेशन में. Then we will start that. Okay, क्लियर हुआ सभी को? Okay, चलिए फिर कल मिलते हैं एट सेम टाइम. वेरी नाइस प्रॉब्लम्स. अभी और प्रॉब्लम करेंगे डायनेमिक्स में, मैनी मोर प्रॉब्लम्स वी विल डू, डोंट वरी. पूरा फुल कंसेप्चुअल. ठीक, चलिए फिर कल मिलते हैं. बाय बाय. जय हिंद, जय भारत.